All right. So we know our definition of a quadratic function, right? It's going to be a quadratic function. And the definition is f of x equals ax squared plus bx plus c, where a, b, c are constants, a cannot equal 0, and then we know that x is the independent variable because it's in the function notation denotes that. So then from there, we know the quadratic formula already, right? It's x equals negative b plus or minus the square root of b squared minus 4ac, and then that whole thing is divided by 2a. Bring it back to the frame here. So now how do we get that? Well, we get that from our quadratic equation. So we have to take this from a quadratic function, we have to put it as a quadratic equation in one variable so we can manipulate it. So we'll say 0 equals ax squared plus bx plus c. And then once we had this, because again this is our quadratic equation in one variable, the variable being x, because a, b, and c are constants, we can use completing the square to find the quadratic formula and solve for x, basically. Well, not basically, that is what we're doing. So now, in order to utilize completing the square, the coefficient of the a term, or the x, the a term, yes, can't be anything other than 1. And now it's a, which is not 1. So we have to get it to be 1 by factoring out the a. So we're going to say 0 equals a x times x squared plus b over a x plus c. Now I could have taken it out of the c term, but it's just a little easier if you don't do that, because you would have to put it back in later, so it doesn't really make a difference. So that's why I only took it out of the a and b terms. So from here, let's simplify this portion, right? We want to get it into, continue completing the square. So we have a times x squared plus b over a times x. And we know to get the c term inside the parentheses, we have to divide b over a, which is the b term, by 2, and then square it. So what we're going to do is we're going to add that b over 2a squared, but that would be changing it, so we have to invoke the additive identity, which is 0, and we have to subtract it as well. So we're not actually changing it, we're just putting stuff in there. So we go 0 over 2a, or b over 2a, sorry, put that in parentheses and plus c. So now what we're going to do is we're going to simplify those. B over ax plus b squared over 4a squared minus b squared over 4a squared plus c equals 0. So then from here, we don't really want this negative b squared over 4a squared term in here, because then that wouldn't be abc, right? We'd have two things here, and that's not quadratic. So we're going to take this out of here, right? So we're going to say a equals x squared plus b over a x plus b squared over 4a squared plus c minus b squared over 4a squared. But we're not done with that yet, because since we took it out of this area here in the parentheses, we have to distribute that a back in. Maybe this is equal to 0. And we have to distribute that a back in, because here, this a belongs to all these terms in here, but if we take one out, we have to put the a back in. So this is multiplied by a. So that would give you 0 equals a times x squared plus b over a x plus b squared over 4a squared plus c minus, that would be b squared times a over 4a squared. And this simplifies the a's divide to be 0 equals a times x squared plus b over a x plus b squared over 4a squared plus c minus b squared over 4a. Now, from here, we're going to continue completing the square inside here, and that's going to end up being x plus b over 2a squared. And then we're also going to start, in the next step, we're going to start simplifying a little bit more. So now this is done in here, but we want to get these terms to this side. So we're going to subtract the c, and we're going to add the b squared over 4a. So if we come up here, we're going to get b squared over 4a minus c equals a x plus b over 2a squared. Now, again, our end goal is to get this x by itself. So what we want to do next is we want to combine this stuff over here. So in order to do that, in order to subtract fractions, because again, this is c over 1 in reality, so we want to have the common denominators in order to subtract fractions from each other. So we have to multiply c over 1 by 4a over 4a, which is our multiplicative identity, because it doesn't change anything because we're multiplying by 1. We're just multiplying it by a very specific version of 1. So we'll say b squared over 4a minus 4ac over 4a. And we can smush this together to say b minus 4ac, because they're both being divided by it. We could just say 4a equals a times x plus b over 2a squared. Now, we can divide both sides by this a here, and that will give us b squared minus 4ac all over 4a squared equals x plus b over 2a squared. Now we get 4a squared because, remember, if you divide a fraction by another fraction, because again this is a over 1, you flip the fraction that you're dividing by and multiply it. So this is really 1 over a. And then you get, that's how you get 4a squared from this. So now, in order to be able to manipulate these terms in here, we have to get rid of this square, right? So we're going to square root both sides. Square root this side, square root this side, and from that we get plus and minus, because you can square a negative number to get a positive number, and you can square a positive number to get a positive number. So it could be either plus or minus. So square root of b squared minus 4ac over 2a, because square root of 4 is 2, square root of a squared is a, equals x plus b over 2a. Now, from here, in order to get x by itself, all you have to do is subtract b over 2a from both sides. We're going to do that on your paper. Oh, excuse me. So, we're going to say what we had up there was plus or minus b squared, square root of b squared minus 4ac over 2a equals x plus b over 2a. And again, we're going to subtract b over 2a from both sides because we want to get this x by itself again. So we get negative b over 2a plus or minus the square root of b squared minus 4ac over 2a equals x. And again, because these are common denominators, we can rewrite this all together as negative b plus or minus the square root of b squared minus 4ac all over 2a equals x. And then that is your proof of the quadratic formula.